Assalamu alaikum students. It's our 10th lab of OOP and data structures. The title of the lab is linked list, in which I will show you that how you will delete a node, and this lab also consists of a doubly and circular linked list. In the previous lab we have done arrays, pointers, and a introduction of linked list, in which I have implement a code in C++ that how you will create a linked list and how you will add a node. In this lab I will show you that how you will delete a node after creating it. First you will create the nodes and then I will show you how to delete the nodes. So for this we will create functions, and then I will also implement the double linked list for you in the form of code, as you have done all these things in your theory course, but I will teach you these things through implementation of code. So here it is the previous labs which we have done. We have done 9 labs in OOP data structures, in which 8 labs were on OOP, while from 9th we have started our data structures. In 9th we have done a little bit introduction of the linear linked list. In this lab we will do the remaining part of linear linked list and doubly and circular linked list. So the main objectives of this lab is to familiarize students with insertion and removal of nodes, because for removing nodes you have to first create nodes, because we cannot remove nodes from an empty linked list. And then finding size of list and displaying list element, meaning that you have to display the elements which you have inserted, and then also after removing you can also display it, that you can know that how many nodes has left. To familiarize with doubly and circular linked list, so we start with singly. This is a little bit of singly linked list which we have already studied, that it consists of nodes. Each node consists of a data and a pointer pointing to the next node. In this we have nodes in which one portion is data while the other is pointer, and we have head and tail node. Tail pointers, in which the head is pointing to the next node while the tail is pointing to the null. So like this all the nodes are connected with each other with the pointer, and the pointer of previous node is pointing to the next node. If you want to insert a node in the linked list, so you can in the last lab we have just insert a node. We didn't check that either to insert the node at the beginning. So in the previous lab we have just create a linked list and then nodes, but here are also you can add nodes at different positions. For example, there you can add a node. If you have already a linked list, then you can add a node at the beginning, after a given node, and at the end of the link. So these are the 3 positions at which you can insert a node. If you have a empty linked list, then it is obviously that you have to insert a node at the beginning. Or if you have already linked list, then you can also insert a node at the beginning. You can also insert a node in the middle after a given node, or at the end of the linked list. So we will discuss it if you want to insert a node at the beginning. So here is a diagram. So this diagram shows that as the head is pointing to the first node, If 2 is our first node, then the head is pointing to the first node. If you want to insert a node, for example 1, so you have to do a code like this, that the head should the head pointer should be assigned to 1 and the pointer of 1 should be assigned to 2. So like this we can insert a node 1 at the beginning. A linked list is shown below. The old linked list is 2, 4, 6, 8, 10. This is our already existing linked list. If we want to add a new node 1 at the first node of the list, then the head pointing to node 2 will now point to node 1, and the next pointer of node 1 will have a memory address of node 2 as shown in figure. So thus the new linked list becomes, so if you want to insert a node at the beginning, so it will be just like this. So for this you have to just change the pointers. You have to for inserting nodes, you have as the head will be pointing to 2, so you have to just change the pointer of the head to 1 and the pointer of 1 to 2. So like this you can add a new node at the beginning. If you want to add a node in the middle, if you are told to insert a node after C or before D or in the middle of the C and D, so you have to just break the connection between C and D, and as the C pointer is pointing to D, so you have to implement a code like this, that the pointer of C should be pointing to F and the F pointer should be pointing to D. So like this we can insert a node between any two nodes. Here a node is given and we have to add a new node after the given node. In the below linked list, A, B, C, D, as E, B, C, D, E is our already existing linked list. If we want to add a node F after node C, then the linked list will look as follows. Thus in the above diagram we check if the given node is present. If it's present, we create a new node F, then we point the next pointer of node C to point to the new node F. The next pointer of node F now points to node D. You have to just change the position of for this you have to create a temp node for this, and then we will assign the temp to F. So like this we can insert nodes between the linked list. If you want to insert the node at the end of the linked list, so for this, as the last pointer of the linked list is pointing to null, so you have to remove that null, and that null should be pointing to another node, and the pointer of the new inserted node, as it is the last node of the linked list, so it should be pointing to the null. So like this we can add a pointer in the end of the linked list. So in the third case, we add a new node at the end of the linked list. Consider we have the same linked list A, B, C, D, mean we have a linked list which consists of the nodes A, B, C, D, E, and we need to add a node F to the end of the list. The linked list will look as shown below after adding the node. Thus we create a new node F, then the tail pointer pointing to null is pointing to F, and the next pointer of node F is pointing to null, because as we have already know that the last node pointer is pointing to null. So for this our last inserted node pointer should be pointing to null. We have implemented all three types of insert functions. So like this you can also implement in a code. So now coming toward that how you can delete a node. So for deleting a node, you should first insert nodes. To delete a node from a linked list, we need to do the following steps. Find previous node of the node to be deleted. Mean if for example here the C node is deleted, So for this we have to find the previous pointer which is pointing to the node which we want to delete, and change the next of previous node. So here we have to change the next pointer, free memory for the node to be deleted, and also the memory of the node, because then this pointer will be pointing to the next node of the deleted nodes. So here is a procedure that you have to first find out the previous node which is pointing to the node that we want to delete, because that pointer will be pointing to the next node, and also you have to delete the data. So now I will implement a code that how you can create a linked list and add nodes, insert nodes, and then how you can delete these nodes. So the first part will be a bit similar to you. So in this code we have insert nodes, we are implementing a single linked list. So as I have implement a code in the previous lab in which I have first declare a node. Here these are the headers. Then we have to create a node, as the node consists of a data and a pointer. So here we are creating a structure node in which the num is the data, while this is the next pointer which will be pointing to the next node. As in the last, as for we have mentioned it in the last code, we were first checking out that either the linked list is empty or not, but in this we have assigned head null, so the linked list is empty, and we will be insert node at the start. So here I have write a function for inserting a node and pass a variable n as the node. So first we will create a new node with this struct node. So struct node static new node is equal to new. The new will be highlighted as this is used for creating a new node. Then we will assign the n to the data. So here the new node num, the data of the new node will be assigned the n, and its pointer will be assigned head. So head should be equal to the new node. So the head will be pointing to the first node which we have created. Here I have write a function for display. I think you will get this issue, that in the previous code we have first checking out that either the linked list is empty or not. If it is empty, so insert the node at the beginning, or otherwise insert it to the next node. Here we have assigned head null, and then the node that we have created assigned to the head. So here the function for display, if head is equal to null, so it will be print that the list is empty, that there are no nodes in it. Then we have create a temp. So the struct node, as we have write the creating a node with the structure, so that struct node static temp, this is the another pointer which will be mean it will be display all the nodes. For example, if the linked list is empty, so it will just display in the output that the list is empty. Then a temp pointer will be pointing to head, and it will display us the data of all the nodes until the temp is not equal to null. Because if the, as here we assign the temp to the head, and we know that if head is equal to null, so the list will be empty. Or if the mean this loop will run until the temp is not equal to run, so it will display all the created nodes for us. Here the next function is the delete function. So in this function, if the head is equal to null, if head is null, mean there is no node in the list. So if there is no node in the list, so it will display that the list is empty. Otherwise, the head num mean the data, the data will be removed. Or then just like this, it will remove next to next nodes. So mean how much time you want to delete the node, so it will delete. This function will be called once. If I call it once, so it will come once and delete one node. And if you have created, now I will show you the output. I have created the number of nodes, and then I have write some numbers of I have called this function. So how many times you call this function, so it will delete the nodes created by the insertion node. So in the main, you have to just call the display function, and then the insert node. Here we have just used the structure. We have implemented this code to structures. So here I have just display the function, so it will give us the nodes. Then I have insert the nodes. The nodes I have insert the 10, 20. I have insert here the 5 nodes, and then it will display us the number of nodes which I have insert. Then here it is 3, 4, 6 times delete item, and we have only 5 nodes. So after this, after 5th delete calling function, it will display a message that the linked list is empty. So here is the output. Here we have first, it is as we have not inserted the elements, the nodes, so we are displaying it, so it will show us that the list is empty. Then it will show us the inserted nodes, then the deleted nodes, and then as we have 5 here, so after 6th position, it will when 5th is deleted, so it will, when 5th is deleted, so after it will tell us that the list is empty. Then at 6th, if we call the function 6 times, so it will also tell us that the list is empty. Now coming towards the doubly linked list, the chain is seen formed. It is telling about that what is doubly linked list, that how it is different from a linear linked list. So the chain is seen formed in singly linked list is in a way that every node has a field next that points to the next node. This continues till the last node where we set the next to null, the end of the list. this it is telling about the singly list, that all the nodes are connecting with each other with one pointer next to, while the last node of a singly linked list, its pointer is pointing to the null, as there is no other node after that. But if there is a head node pointer, that points to the start of the node, as we have a head node which is pointing to the start of the list. Moving forward is easy in single linked list, as moving forward, but going back is difficult, because if we have a node 2, so it has no idea of what is at node 1 in single linked list. But so the moving forward is easy in single linked list, but going back is difficult. For moving backward, we have to go at the start of the list and begin from there. The above problem is solved by the double linked list. So this problem is solved by the double linked list. In doubly linked list, we use 2 pointers in the node, one to point to the next node and the other to point to the previous node. Mean in a single node, now we will have 2 pointers, one pointer pointing to the next node while one pointer pointing to the previous node, and in which every node has a next pointer and a back pointer. Every node contains the address of the next node except the last one. Mean the last one will have only the address of the previous, as the last node will be the last, so it next pointer will be pointing to null, and every node contains the address of the previous node except the first node. So only the first node will have we don't have a pointer previous, while it will be pointing only the next node. So only the first node will have the address, the pointer of the will be pointing to the next node. A doubly linked list can be traversed in either direction. So its node will be just like this: the element data, previous pointer and next pointer. So the first part is previous, the pointer pointing to the previous node. The second part is the data. Sometimes we call it a data or element containing the data to be inserted in the list. The third part is the next pointer that points to the next node of the list. The objective of previous is to store the address of the previous node. The doubly linked list can be shown as follow. So the head will be pointing to the next, and but head will be not pointing to the previous, and the last node will be pointing to the previous but not pointing to the next. So if we talk about its algorithm, when doubly linked list is empty, which is indicated by head is equal to null, or as we have already studied it in the singly linked list, if the head is null, so it's mean that the linked list is empty. So in the case of doubly linked list, it is the same. If head is equal to null, the insertion is quite simple. Algorithm sets both head and tail to point to the new node. In this case, new node is inserted right before the current head node. It can be done in 3 steps. Update the next link of a new node to the point to the current head node. Update the previous link of the current head node to the new node. Update head link to the point to the new node. Its insertion will be just like same as we have insert the node in the singly linked list. That first we have to check the head. If the head is null, then we will insert a node, and the head will be pointing to that new node, while the pointer of that node will be pointing to null, as there will be no other node after that. So in this case, new node is inserted right after the current tail node. It can be done in 4 steps. But if you are inserting a new node after the first node, So you have to update the next link of the current tail node to point to the new node, update the next link of the new node to null, update the previous link of the new node to the current tail node, update tail link to point to the new node. Mean it will involve 4 steps. So if you want to insert right after the current tail node, already the one node is created and then you have to create another node. So for this you have to update the next link of the current tail node to the point to the new node, update the next link of the new node to null, because as there will be no node after that, so it will be pointing to null. Update the previous link of the new node to current tail node, update tail link to point to new node. Generally a new node is always inserted between two nodes which are already in the list, head and tail. Links are not updated in this case. Such an insert can be done in 2 steps. Update link of the previous node to point to the new node in both directions. Update link of the new node to point to the next node in both directions. So here are different cases when you have to insert a node. So here is a code which I have implemented for you for doubly linked list. In this case I have implemented the code through classes. In this there will be 3 CPP files. Here the one CPP file I have create a node class, the class node. Here I have privately declare its members. At the node of the doubly linked list include data, the next pointer and the previous pointer. So here I have declared the data which is integer, the pointer, next node and the previous node. These are the 2 pointers of the node of the doubly linked list. So publicly I have define the functions. Here in the first, it is a constructor passing one variable a. In this, as we have declared data, so I have assigned this value to data and assign null to both the pointers. So what it means that both the pointers are null, so the linked list is empty. Then a function int get data, it will give us the data which we insert through nodes. It will give us the data of the nodes. Set data is the pointer, that the pointer will assign data to node. This data is equal to data. Then get next is a pointer, it will return us the next node. The get previous node, as if you are seeing here, it is a node which is the class. So these pointers are declared with the name of the class. So it will give us the pointers, the next node and the previous node, these pointers. The void set next, it will I have the pass the next node. We have declared 2 pointers, next node and previous node, which are the part of the node. So in the set next, this will be assigned to the next node, and in the other function this previous node will assign this previous node. So we will use these functions and pointers in our code. So this is one CPP file which I will save with the name of node.cpp. So like this you can call it by just including its name, as we just include node.cpp, so this previous file will be included to this file. So here I have mentioned the class list. In this I have create a head node, and then size, and then current node. I have created two pointers. One pointer will be pointing to the head, while one will be pointing to current. And list, this is our constructor, default constructor, in which all these three items will be assigned 0, as the two pointers will be assigned null and the size will be assigned 0. Now as for assigning the 0, it means that there are no nodes in the linked list. So through this function we will add nodes to the linked list. So add nodes, this is a function add nodes, in which we are passing a variable a. So node static new node, node is the name of the class in which we have mentioned in our previous file, and new node is a pointer which will create new. If you write new, so it will be highlighted, but in will we create a new node having a. So if the size is equal to 0, mean the head node is equal to new node, so the current node is equal to new node. Mean if the size is equal to 0, so the head node will be assigned the new node and the current node will be assigned the new node. Mean we are creating a linked list, so the new node will be the head. Else फिर क्या करेगा, new node set next, current node get next, and new node set previous current node. If the linked list is empty, so it will just create a new node. But if the linked list is not empty, so the next node will be assigned, mean we will create two pointers. The next, mean if we are creating a node, so it must have a next pointer and a previous pointer. So the current node mean that set next new node, and the current node is equal to new node, and like this the size will be increasing. Mean like this you have to insert nodes like this. Mean the set next pointers will be assigned to the new nodes, and as we have told and we have said that the head is not pointing to the previous nodes. So the next function coming towards is the display data. So here we have declaring a temp pointer. The temp will be assigned to the head node. So the head node and the double linked list data is, so it will assign the linked list data. And if the temp, while we will assign a loop while temp is not equal to null, mean that first it is assigned to the head, so it will goes until the temp is not equal to null, mean it will be goes until the end point, the end node. So it will mean display all the nodes which we have inserted. So it is just like this. And here the display reverse, it will simply reverse our nodes. So here I is equal to size, as we have mentioned the size in our insert nodes. So the node temp is equal to the current node, mean the current node, and it will go into the minus mean it will first take the last node first, and then the, mean just look at, see how temp get data, and then it will goes to the minus and then temp to the previous, mean it will takes us to the previous nodes like this. Here is the main we have just here this is the list file. So in the main we will include it. So there are 3 cpp files here. We have include the list.cpp in the third file. In the list cpp file we have include the node cpp, while in this we have include the list in the main. So here we have create an object li, and then li we have create the nodes till 7, then we have display the data, and then we have just display the reverse data. So here we have the 1 to 7, and then it is in the reverse order. So coming towards the circular linked list, the circular singly linked list is little different from the singly linked list. It is same as the single linked list, that it has a nodes, and the node consists of a data, and the node consists of a pointer pointing to the next node. But it has a one thing different, that the last node will be pointing to the first node. Here is this difference of the circular linked list from the singly linked list, and also from the doubly linked list. So a singly linked list is singly linked list which has the last element linked to the first element in the list. Being circular, it really has no ends. Then we will use only one pointer to indicate one element in the list, the newest element. We have a list with 5 elements. We have connected the last node with the first node. It means that the next of the last node is pointing towards the first. So it can be also its diagram can be also shown in a circular way, that it is the last node is pointing again to the head. So it is all the 3 linked lists, the singly linked list, the doubly linked list, and the circular linked list. As you have already learned them in your theory, I have just implement their codes in this lab, and hope you will get it. The lab task is about you have to implement the doubly linked list as I have implemented, but you have to ask the data, the nodes from the user, while I have not implement the circular linked list. So you have to implement just implement the circular linked list, create a circular linked list, and display all the list elements. And I hope that it's enough for this lab, and आप लोगों को समझ आ गई होगी. If you have any questions regarding this lab, you can ask in the interactive session, or you can contact me through this email. Thank you.